Chapter 6: The Environment and Change Over Time. Lesson 1: Fossil Evidence of Evolution. The fossil record. On the way to school, you might have seen an oak tree or a heather robin. Although these organisms shed leaves or feathers, their characteristics remain the same from day to day. It might seem as if they have been on Earth forever. However, if you were trees or robins, you would see different species of trees and birds. That is because species change over time. You might already know that fossils are remains of evidence of once living organisms. The fossil record is made up of all fossils ever discovered on Earth. It contains millions of fossils that represent many thousands of species. Most of these are no longer alive on Earth. The fossil record provides evidence that species have changed over time. Fossils help scientists picture what these species look like. Figure 1 shows how scientists think the giant bird Titanius might have looked like when it was alive. The image is based on fossils that have been discovered and are represented in the photo of the previous page. The fossil recorder is enormous, but it is still incomplete. Scientists think it represents only a small fraction of all organisms that have ever lived Earth. Fossil formation. If you have ever seen vultures or other animals eating the dead animal, you know they leave little behind. Any soft animal, you know they leave little behind. Any soft tissues animals do not eat. Bacteria break down only the dead animals' hard parts such as bones, shells, and teeth remain in. However, under rare conditions, some become fossils. The small tissues of animals and plants such as skin, muscle, and leaves can also become fossils, but these are even more rare. Some of the ways that fossils can form are shown in Table 1. Mineralization. After an organism dies, its body could be buried under mud, sand, or other sediments in a stream or river. If minerals in the water replace the organism's original material and harden into rock, a fossil forms. The process is called mineralization. Mineral in water also can filter into the small spaces of a dead organism, tissues and become rock. Most mineralized fossils are of shell of bone, but wood can also be a mineralized fossil, as shown in Table 1. Carbonization. In carbonization, a fossil forms when a dead organism is compressed over time, and pressure drives off the organism's liquid and gases. As shown in Table 1, only the carbon outline of the film of the organisms remain. Molds and casts. Sometimes when organisms die, its shell or bone might make an impression in mud or sand. When the sediment hardens, so does the impression. The impression of the organism in a rock is called a mold. Sediments can later fill in the mold and harden to form a cast. A cast is a fossil copy on an organism in a rock. A single organism can form both a mold and a cast. Shown in Table 1, molds and casts show only external features of organisms. Trace fossils. Evidence of an organism's movement or behavior, not just its physical structure, also can be preserved in rock. A trace fossil is the preserved evidence of the activity of an organism. For example, an organism might walk across mud. These tracks, such as the ones shown in Table 1, can fossilize if they are filled with sediment that hardens. Original material. In rare cases, the original tissues of an organism can be preserved. For example, of original material, fossils include mammoths frozen in ice and saber-toothed cats preserved in tar pits. Fossilized remains of ancient humans have been found in bogs. Most of these fossils are younger than 10,000 years old. However, the insect encased in amber in Table 1 is millions of years old. Scientists also have found original tissue preserved in the bone of a dinosaur that lived 70 million years ago. Determining a fossil's age, scientists cannot date most fossils directly. Instead, they date the rocks of the fossils are embedded inside. Rocks erode are recycled over time. However, scientists can determine ages for most of Earth's rock. Relative age dating. How does your age compare to the ages of those around you? You might be younger than a brother but older than a sister. This is your relative age. Similarly, a rock is either older or younger than rocks nearby. In relative age dating, scientists determine the relative in order in which rock layers are deposited in an undisturbed rock formation. They know that bottom layers are oldest and the top layers are youngest. As shown in Figure 2, relative age dating shows scientists determine the relative dating order in which species have appeared on Earth over time. Absolute age dating. Absolute age dating is precise than relative age dating. Scientists take advantage of radioactive decay, a natural clockwise process in rocks, to learn a rock absolute age or its age in years. In radioactive decay, unstable isotopes in rocks change into stable isotopes over time. Scientists measure the radio of ages of the rock. This state radio is best measured in igneous rock. Igneous rocks form from volcanic magma. Magma is so hot it is rare for parts of organisms in it to remain and form fossils. Most fossils form in sediments, which become sedimentary in rock. To measure the age sedimentary rock layers, scientists calculate the ages of igneous layers above and below them. In this way, they can estimate the ages of fossils embedded within the sedimentary layers as shown in Figure 2. Fossils over time. How old do you think Earth's oldest fossils are? You might be surprised to learn that evidence of microscopic unicellular organisms have been found in rocks in 3.4 billion years old. The oldest fossils visible to the unaided eye are about 565 million years old. The geologic timescale. It is hard to keep track of time that is millions and billions of years long. Scientists organize Earth's history into a timeline called the geologic timescale. The geologic timescale is a chart that divides Earth's history into different time units. The longest time unit in the geological timescale are eons. As shown in Figure 3, Earth's history is divided into 4 eons. Earth's most recent eon, the Phanerozoic eon, is subdivided into 3 eras, shown in Figure 3. Dividing time. You might have noticed in Figure 3 that either eons or eras are equal in lengths when scientists began developing the geologic timescale in the 18s. They did not have absolute age dating methods to mark time boundaries. They used fossils. Fossils provide an easy way to mark time. Scientists know that different rock layers contain different types of fossils. Some of the fossils scientists use to mark time boundaries are shown in Figure 3. Often a type of fossil found in one rock layer did not appear in layers above it. Even more surprising, entire collections of fossils in one layer were sometimes absent from layers above them. It seemed as if whole communities of organisms had suddenly disappeared. Extinctions. Scientists now understand the sudden disappearances of fossils in rock layers are evidence of extinction. Extinction occurs when the last individual organism of a Species die. A mass extinction occurs when many species become extinct within a few million years or less. The fossil record contains evidence that 5 mass extinction events have occurred occur at other times. On smaller scale, evidence from the fossil record suggests extinctions have been common throughout Earth's history. Environmental change, which causes extinctions. Populations of organisms depend on resources in their environment for food and shelter. Sometimes environments change. After a change happens, individual organisms of a species might not be able to find the resources and they need to survive. When this happens, the organisms die and the species become extinct. Sudden changes, extinctions can occur while environments can change quickly. A volcanic eruption of a meteorite impact can throw ash and dust into the atmosphere, blocking sunlight for many years. This can affect global climate and food webs. Scientists hypothesize that the impact of a huge meteorite 65 million years ago contributed to the extinction of dinosaurs. Gradual change. Not all environmental change is sudden. Depending on the location, Earth's tectonic plates move between 1 to 15 centimeters each year. As plates move and collide with each other over time, mountains form and oceans develop. If a mountain range or an ocean isolates a species, the species might become extinct if it cannot find the resource it needs. Species also might become extinct if sea level changes. Extinction and evolution. The fossil record contains clear evidence of the extinction of species over time, but it also contains evidence of the appearance of many new species. How do new species arise? Many early scientists thought that each species alive appeared on Earth independently of each other species. However, as more fossils were discovered, patterns in this fossil record began to emerge. Many fossil species in nearby rock layers have similar body parts and similar structures. It also appeared as if they were related. For example, the series of horse fossils in Figure 5 suggests that the modern horse is related to the extinct species. These species change over time in what appeared to be a sequence. Change over time is evolution. Biological evolution is change over time in populations of related organisms. Charles Darwin developed a theory about how species evolve from other species. You will read about Darwin's theory in the next lesson.